speaker is a prolific speaker, so to say. I have experienced him. It's very early morning for Dale. Sorry, Dale, once again to wake you up in the very wee hours. Yeah. So Dale has been a very good technical person. 1M2M could have had. He has had loads and loads of experience in his IoT M2M area, and he has been providing a lot of depth to 1M2M specification. He's 1M2M TP Vice Chair, so without much ado, I should move away and let Dale come forward with his interworking framework of 1M2M, which is a very, very important aspect of 1M2M. Over to you, Dale. Thank you.
Thank you, Arindam, and thanks, Pamela, for the great keynote. I think that touched upon a lot of important things that we need to do next in India, as well as have a good talk about today. It's great to see from Professor Deepak the great progress being made at IIIT in Hyderabad too since our last visit. It's great to see all the great work going on there, and look forward to hearing more about that. So today, I was asked to speak to you a bit more about interworking. So we have two talks today. My talk will go first. We'll talk a little bit more about the different types of interworking, and then we'll follow up with Bob Flynn has a talk zeroing in more specifically on the 3GPP. So I think both are very complementary to one another. So here on my first slide, what I'm showing here is just the 1M2M standard and the service layer, the middleware layer, as we call it sometimes, and the different entities and stakeholders that are part of a typical IoT deployment. And the interworking aspect of the standard really touches upon all of these different stakeholders, whether it's the traditional IoT devices or data sources that we see at the bottom, typically feeding the data into the platform, or whether it's the application developers that are trying to interact with the devices, sample the data, or control the devices, or perhaps the service providers that are trying to deploy the services at the end of the day, or maybe it's a data insight provider, like an analytics provider, or perhaps an AI or ML type of service that's trying to layer over top of 1M2M or an IoT platform that supports 1M2M. All of these different entities and stakeholders can benefit from interworking. And we'll walk through this presentation today and give you a little bit better flavor of what 1M2M does from the perspective of interworking and why it's so important from an IoT perspective. So if we go to the next slide, please. So here on this slide, I'm showing a very typical IoT deployment and how it has an end-to-end nature to it, right? On the left-hand side, what we typically find in any IoT deployment is we have either IoT devices that are deployed in the field, or perhaps some legacy data that sits in some database somewhere that needs to be interworked and interfaced into the system as well. So in many cases, we don't have the luxury of deploying and starting from a fresh start where we can deploy, let's say, 1M2M all the way down onto the devices themselves. Many times you're walking into a deployment where there's existing technology, existing investment sitting there somewhere in the system. In this case, we're showing it on the IoT device end where we have some non-1M2M devices. Here, these happen to be some narrowband IoT devices. They're deployed on some street lamps. And these different street lamps are interworking in through some edge node, some gateway node. And they're talking into a cloud platform. That cloud platform has some data storage associated with it, as well as some applications in the back end that are either trying to display the information about the devices or perhaps even control them. This is a very typical IoT system. If we go to the next slide. Here on this slide, we're just showing some different examples of where it may make sense to deploy 1M2M from a standards perspective. And we're showing 1M2M being deployed on the cloud at the IoT platform level in the cloud, also within the database that's attached to the cloud. So the standard can provide the data model, the information model, standardization of data that's stored within the database. And then also we could have some OneM2M based applications, whether they're the dashboard or the controlling aspect in the back end. So these are a very typical type of deployment of OneM2M, where you're trying to interwork in, let's say, non-OneM2M devices. And then on the device side, we've got a gateway node that has some level of non-OneM2M functionality that talks to the devices. And it has a bit of OneM2M technology that we'll talk a little bit about later, about what we typically call an IPE, or interworking proxy entity. That's basically what makes up the gateway, and that enables interworking in these devices into the service layer. So if we go to the next slide, please. What's often not advertised much from a OneM2M perspective is the ability not just to interwork, let's say, non-OneM2M devices into the system, but also the ability to interwork in non-OneM2M applications or services from other places. So here I'm showing a good example of just an analytics service. So not all applications or services need to be OneM2M either. That's always not, that also is not always possible. So if we take an existing service and we want to have that service be able to pull data out of, let's say, a database containing OneM2M sensor values or readings, I think we saw this on Professor Deepak's slides, where we had the Indian Urban Data Exchange. That would be a very good example of how we can interwork in non-OneM2M services into the overall system. And again, that's done in a very similar fashion, where we can use some interworking proxy type of functionality and allow those types of services to access the platform as well. And that's a very important piece into the overall ecosystem. Next slide, please. And here we just scale out the system some more. So we add in some additional technologies. We add in some more devices. Again, these devices don't necessarily need to be OneM2M centric. They can be, of course, if we've got the ability to design from scratch. But in many cases, in many IoT deployments, that's not always possible, just due to the existing brownfield deployments and the investment that's going into them. So here we interwork in even more types of devices. We pull them into the platform and we scale it out, we build it out. Next slide, please. So here's just another look at, we've talked about the requirement in many IoT deployments is you're typically taking technologies from all different places, all different flavors. So here we're showing many different types of devices, whether they be Zigbee, Bluetooth, C-Wave, Modbus, 3GPP, which we'll hear more about from Bob Flynn in the discussion after mine, and many more. That's going to be a typical trend in any IoT type of deployment. And one of the big messages I want to get across today is, when OneM2M was being developed, and as it continues to be developed today from a standards perspective, we embraced this type of ecosystem and this type of deployment model, knowing that this would be the deployment model for most IoT deployments, where we would need a technology to bridge and interwork all of these types of technologies together. And that is the value add propositions for OneM2M, is to be able to provide that technology that abstracts away the lower level connectivity and even the upper layer information models of these different technologies, and provides an abstraction layer to allow application developers and service providers not have to worry about these different technologies, and use OneM2M to work at a little bit more higher level layer of technology when it comes to deploying IoT in these different use cases. So let's take a little bit closer look on how that's possible. So if we go to the next slide, please. So here on this slide, what I'm showing is a typical stack when it comes from an IoT deployment. And with any protocol stack, you have some layering going on. So if we just take a quick pass over this protocol stack here, is one of the messages I'd like to get across is, depending on the type of device and the technology associated with that device, you typically have some level of a stack that gets built over top of these devices. You have some type of connectivity, whether it's cellular, fixed, Wi-Fi, just as some examples. And then over top of that connectivity logic, you have some level of protocols. So whether you use TCP and TLS, or maybe you use DTLS and UDP, that's some level of transport level protocols that are typically layered over top of your connectivity. And then over top of your transport layer, you typically have some level of application protocol, whether it's HTTP, CoAP, MQTT. And then over top of that, you start getting into the data modeling. So you'll have some type of serialization, some XML, JSON, CBOR, for example. And over top of that, you may start to build out some types of services. You may use some lightweight M2M, some OCF, some device management protocols. And then finally, you may start getting into some semantics, whether you're using some Serif information models, whether you're using the OneM2M information model, whether you're using the W3C thing description. There's all different types of information models out there as well. So what I'm trying to get at here is, depending on the type of device and the type of technology you're using, the application developer may have to worry about all these different types of protocols if they're not using a technology like OneM2M. And that translates into a lot of complexity for the application developer, because they may need to worry about all different types of protocol stacks. And that creates a lot of pain from an application developer, debug, and a lot of cost, a lot of interoperability issues. So if we go to the next slide. Here on this slide, what we're trying to show you is the value proposition of OneM2M. What OneM2M is trying to do is really abstract away some of the lower level complexity that we often see in many IoT deployments, where we can take the OneM2M service layer, we can insert it in over top of all of this complexity that we saw there on the left. And what we're left with is, we're left with an API and a level of abstraction that the application developers or the service providers can then bolt into, and really not have to worry about the lower level technologies. And that's the concept of abstraction. And that's the real, one of the major benefits of OneM2M, is being able to do that for all different types of technology. And depending on your deployment, you may leverage OneM2M to abstract away different levels of protocol stacks, depending on your use case. And that's again the real flexible aspect of OneM2M as well. So if we go to the next slide. So let's take a look at an actual example. So what we're showing here on these next set of slides is, if you're an application developer and you want to talk to various types of devices, but those devices all provide a similar capability or similar function, whether it's, you have some sensors deployed in the field, and those sensors are using different types of technology, or in this case, I'm showing you some more actuator type of use case, where we actually want to control something in the field. It happens to be a light here, so it could be the street lights that we saw in the prior example early in the presentation. Those sensors or those actuators may be deployed using all different types of technology, and we may interwork them into the platform here using some edge nodes, some gateway nodes that we call, in OneM2M terms, we call these interworking proxy entities. But you could think of them as just gateways. These gateways are responsible for talking the lower level protocols, as well as having a very thin OneM2M client to allow them to interwork in and talk to the OneM2M service layer as well. So what we're showing here is, we have an application developer at the top that is sending a single request down into the OneM2M service layer. And if we go to the next slide, we have functionality into the OneM2M service layer that receives that request and is able to take a single request and fan it out to a group of nodes using the OneM2M group functionality. And when that fan out happens, it sends the OneM2M request down to the different IPEs, the interworking proxy entities for the respective different technologies, as well as in this case, we're also showing a OneM2M native OneM2M light as well. So, and I wanted to show this from the perspective that devices themselves could also be OneM2M devices. If you have the ability to roll out fresh devices and new devices in your implementation, you can do that all the way down to the device level. So here we're fanning out the 4 requests down to these devices. And then if we go to the next slide, please. Then what happens is the IPEs will then interwork them in, send these requests to the respective devices for each of these different technologies, as well as the requests flowing down to the OneM2M devices. And then if we go to the next slide, these devices process the request in their own native technologies. They respond back in their own native technologies. Those responses flow into the interworking proxies, as well as back into, from the OneM2M perspective, that goes directly back into the service layer. And if we go to the next slide, the interworking proxies then take these responses, convert them back into the OneM2M responses, which flow back into the service layer. And if we go to the next slide, then what happens within the OneM2M service layer is these responses are aggregated. So the grouping functionality within the service layer takes the individual responses, aggregates them into a single response. That response is then returned to the application developer, and the application developer really was not aware of the fact that their one request that they sent down into the service layer was actually translated into separate requests. Those requests were fanned out, sent down to the devices received, processed those requests. The application developer was not aware of any of that. From the application developer's perspective, he's just getting a single OneM2M request in response coming back from his request, and his life is much simpler. And he, at the end of the day, the application developer sees a lot of value from that. So this was an example just to demonstrate the power of abstraction and the power of the OneM2M service layer and the interworking capability. So if we go to the next slide. So I'll wrap it up here with just some of the takeaways. So the first takeaway is, when OneM2M was developed, we went into that with our eyes wide open, knowing that many IoT deployments would be very diverse in nature. They would be consisting of many different types of devices, different types of data, different types of subsystems from different service providers. And we really wanted to build a technology that would serve those types of deployments and that would offer the ability, coming to my second point on the slide, to really abstract away that complexity, to really reduce the complexity in the overall system, especially from the stakeholders such as the application providers, the service providers, and provide that level of technology that was missing in the IoT ecosystem. And the reason why we wanted to bring this technology in from a standards perspective is really help with future-proofing IoT deployments. Having that ability to take these different types of technologies and interwork them together and provide a path forward for the different stakeholders to try to future-proof their investment as well as their technology. And that's really where OneM2M was really thought of as a technology that could provide value into the standardization ecosystem. So hopefully my talk today gave you a little bit better idea of interworking and the different forms of interworking. And hopefully this serves as a good segue for Bob Flynn, who will talk to us next about zeroing in on the 3GPP interworking aspect and some of the features and functionality that we have in OneM2M to specifically target that technology as well. So again, thank you for your time today, and I'll turn it back over to you, Arundam, and thank you very much.
Yeah, thanks, Dale. Thank you very much once again. So